Today we're going to learn about scatter plots. So yesterday we talked about the relationship between two categorical variables, and we talked about that we could show that using a segmented bar chart. This was our segmented bar chart from yesterday. This was the Titanic example that we did. And so that was categorical variables. All right, so there's a category for the x-axis, the explanatory variable. There is a category for the response variable, survival status. But what if we want to look at two quantitative variables? Anybody have a guess what we're going to use? What? Yeah, we're going to use a scatter plot. So we're going to use a scatter plot. A scatter plot shows the relationship between two quantitative variables measured on the same individuals. All right. So if I were to ask each of you two quantitative variables, like your age and your GPA, then I could plot that on a scatter plot. The values of one variable appear on the horizontal or the explanatory variable, and the values of the other variable are on the vertical axis or the response variable. Each individual in the data set appears as a point on the graph. So every one of these dots is an individual that has two characteristics, one of them being whatever's on the x, the other being whatever's on the y. Cool? Cool. So, how do we make a scatter plot? You don't know? I'm going to tell you. It's going to be great. Maybe. Please. Thank you. Here's how we make a scatter plot, ladies and gentlemen. First of all, you need to identify the variables and label your axes. Identify your variables and label your axes. We're going to put the explanatory variable on the horizontal or x-axis. We're going to put the response variable on the vertical or y-axis. If there is no explanatory variable, either variable can go on the horizontal axis. So actually you can flip them. Doesn't really matter. All right, scale the axis. You do have to include a scale, meaning you have to have numbers. All right? Are you two keeping up with me?
Yes.
Yeah. All right. Scale the axis. We're going to place equally spaced tick marks along the axis beginning at the number equal to or less than the smallest number. And we're going to go as high as the largest number. We do that for the x and the y axis. Please notice something. The axes don't have to be scaled the same way. On this example, the x-axis starts at 1 and goes to 4, and it's marked by 1s. On the y-axis, it goes from 50 to 450 and marked by 50s. So they don't have to be the same way, okay? And then you plot each data value, x and y, just like a coordinate, like when you were doing coordinates back in middle school, okay? For each individual, you're going to plot a point directly above that individual's value for the explanatory and directly to the right for the y-axis, okay? All right. Are we bored yet? Because we know how to do this, don't we? Yes, we do. Yes, we do, people. We're going to make a scatter plot, okay? All right. We're going to do an activity today. Are you excited?
Yeah.
Heck yeah, you are. It's a candy grab activity. So here's what you're going to do. In this activity, you're going to investigate whether students with larger hand spans, what's a hand span? Can grab more candy than students with a smaller hand span. So here's what a hand span is. It is on your dominant hand, so whatever hand you write with. On your dominant hand, you're going to spread your fingers out as wide as you can without getting a cramp. And you're going to measure the distance from the tip of your thumb to the tip of your pinky finger. Okay, so this distance right here. So with your hand spread out, you're going to measure this distance in centimeters, okay? And then what you're going to do is I'm going to have a bucket, and one person at a time will reach into the bucket with your dominant hand down, okay? We're not scooping like this. You have to keep your hand down. And you're gonna reach into the bucket and you're going to grab the candy, as many as you can, and lift it out. Hold it there for 2 seconds and then count how many candies you grabbed. Okay? Then you're going to mark on the board. I'm gonna have a chart on the board, like the one you have below. And you're gonna put your hand span in centimeters and the number of candies that you were able to select or grab, okay? While everyone else is doing this, so people are going to be, one at a time, they're going to do it, and then they're going to mark it down, and then they're going to go, okay? You are going to construct a scatter plot. So the scatter plot's actually going to be on your next page there, okay? So if you, open up your notes, both sides, you can kind of see it. Now, you are gonna you are gonna have to wait just a little bit to kind of see what kind of the lowest number is gonna be and what the highest number is gonna be. So we're gonna have to kind of give it a little bit. About half the class will probably be able to tell how many. So we're gonna do that, and then we're gonna make sure we scale it. We're gonna label it. It's gonna be fantastic. Are you guys excited?
Yeah.
Yeah, you are. Let's freaking go. All right. Now, one other thing about your hand span. When you guys measure your hand span, make sure you do it in half, round to the nearest half of a centimeter. Okay? So you can be like, is it half or 1? Hang on. What did it say to do? To the nearest half of a centimeter, yeah. So 3.5 centimeters. If your hand is 3.5 centimeters, you should be in the Guinness Book of World Records because that would be really small. Okay. All right, cool. So I'm going to get the candy set up. If you want to go ahead and draw your X and Y axis, but obviously you don't know what the numbers are, but so you can draw a big fat L. Not that y'all are losers. All right, and then I'm going to get the candy ready. Cool. Come on, there we go. All right, so we have our data. We've started to sketch our scatter plot. Maybe you're done, but we're going to go ahead and look and see how to do this on our calculator. So we've sketched it best we can, but here's how we're going to do it on the calculator. So here we go. We're going to first input the data into our calculator. Do you guys know how to put data into your calculator? Stat edit. Okay, stat edit. I would suggest you go ahead and write down the steps first, and then we'll do it. So stat edit, you're going to put your explanatory variable, that's your x-axis, the hand span is going to go into L1. The response variable is going to go into L2. Then you're going to make sure that you keep the values matched up, okay? You have to make sure that they're matched up. You're going to turn on your stat plot. To do that, you go to second and y equals. Stat plot is under second and y equals.
Do we do that before we go into stat edit?
No. So this is the order you got to go in. You got to put the data in first, stat edit. Then you go to stat plot, which is second y equals. Second and y equals. That's where your stat plot button is. Okay, then you're going to see it says enter on number 1. You're going to want to hit enter on number 1, which is the stat plot 1. So you'll hit enter on that. Then you want to make sure you hit enter on the word on. That should then highlight the word on, and off should be not highlighted. Then you want to be sure that the first graph type is highlighted. It kind of looks like a dotted line up, down, then back up. And that's that first graph type. You're definitely going to want to make sure that one's highlighted. Look at where it says X list. It should say L1. If it does not say L1, then you're going to want to put second and the number 1 to make it say L1. That is, of course, if you put your data into the explanatory into L1. Then your Y list should say L2. That is second and the number 2. Now you're going to actually view the graph. So you're going to hit graph on the top right of your calculator. It's not going to be in the correct window setting. So what you can do, a quick way to get there, is to hit zoom and the number 9. That's the zoom stat. So zoom 9. And then if you should see the scatter plot. And then if you hit trace, which is in the middle of the screen across the top, you can toggle left and right and you can see all of your different data values. It does go in order of the list. It does not go from highest to lowest or anything like that. It goes in order of the list. So sometimes you have to do, just kind of keep cycling through until you get to the data point that you're interested in seeing. All right, so that's how we do a scatter plot on our calculator. And so let's go ahead and plug all of our data in and let's see what we see. All right, so using those steps, we make a scatter plot on our calculator. Now, does the calculator scatter plot look pretty similar to what you sketched? Hopefully that answer is yes. All right, hopefully it looks pretty close. And then what does this graph tell us about the relationship between handspan and the number of candies? So what we can see is that the trend is positive. So what that means is as hand span increases, the number of candies picked up also increases. So we have a positive relationship. Both of them are increasing together. Okay, so that's how we make a scatter plot in our calculator. And now we'll talk about describing a scatter plot. So yesterday we made a scatter plot in our calculator. We sketched it. We were like, okay, this is exciting. It took us 87 years, and we sketched the scatter plot. And then we did it in the calculator, and it took us like 5 seconds. So which method do you think you'll probably use in the future? I would recommend you'll probably use your calculator, which is totally acceptable. Now, some people get a little bit, upset if they do it in their calculator and then they try to sketch it and they can't get it exactly perfect. It's okay, okay? It's okay if you can't get your dots to look exactly like your calculator. If you've sketched it, you've labeled your axes, and you've marked the values, and you're close-ish, then that's going to be good enough, okay? So I don't want you to worry too much about what if it doesn't look exactly right. It's probably close enough. All right, so what we're going to talk about today is we're going to talk about how to tell now if there's a relationship between these two quantitative variables. So to describe a scatter plot, remember back in chapter 1 when we were describing histograms and dot plots, we used an acronym SOX. Do you guys remember what SOX stands for? Shape, outlier, center, spread. Boom! Shape, outlier, center, and spread. Very good. So that was for one quantitative variable. We now have 2 quantitative variables on a scatter plot. And it would not make any sense to use SOX on a scatter plot. None. 0 cents. So we're going to use this. We're going to use direction, outliers, form, and strength, which is DOFs, which doesn't sound as cool as SOX, but it is basically the same thing. So DOFs, direction, outliers, form, and strength. Direction, outliers, form, and strength. It's not as cool. So if I say, hey guys, what does DOF stand for? Doesn't sound as fun, right? But that's what it stands for. So, DOFs, direction, outliers, form, and strength. Everybody have those written down? Yes? Okay, cool. So, how does this work? To describe a scatter plot, you're going to make sure to use both variable names, and you're going to address these 4 characteristics. Direction. You're going to tell if it is a positive association. So basically, are the dots moving in a positive direction? Is it a negative association? So the dots are moving in a negative direction. Or is there really no association? Literally, you can't tell what direction things are going. It's just dots on a plot, right? Basically, you're just looking at the overall trend of the data to see its direction. That's how you do direction. Outliers. Outliers are going to be individual points that fall outside the overall pattern of the relationship. Outliers are going to be individual points that fall outside the overall pattern of the relationship. Basically, you look at it and you're like, oh, that guy's outside the pattern. There you go. There's an outlier. Pretty easy to identify. Form. A scatter plot is going to either show a linear form or a non-linear form. Basically, when you look at the scatter plot, can you kind of visualize a line or can you not? Does it look curved or does it look linear? That's basically what you're looking at. So linear or not linear. So that's your form. And then your strength. For strength, this is just kind of basically what we're going to go with for now. And then I'll show you guys next week how to tell actual strength. But for now, we're going to go with, is it weak, moderate, or strong association? Basically what that means is how close are the dots to making a line? Are they kind of like super strong toward making a line? Or are they kind of weak where you can just barely see where a line might go? Okay? Weak, moderate, or strong. Those are your strengths. So what does DOF stand for?
Direction, outlier, form.
Direction, outlier, form, and strength. Direction, positive, negative, or none. Outliers, you just notate if there's any. Form, linear or not. Strength, weak, moderate, or strong. Cool? Cool, let's try it. We're going to describe the relationships of these two scatter plots. So let's look at this first one. What do you guys think? What is the direction of this scatter plot?
No. Less skewed. Less skewed.
There's you don't use skewness on a scatter plot. I just said that. Your options are, is it positive, negative, or none?
Positive.
Thank you. All right, direction. This is a positive association. Oh my gosh. Outliers. Do you guys think that there are any data values that are outside of the general pattern that you see there?
No.
Not really. I would agree. D. Oh, what's next?
Form.
F for form. Do you guys think this is a linear form or a non-linear form?
Non-linear.
Which one?
Linear.
Non-linear. Curve.
So yeah, that is non-linear. It is kind of curving. That is actually an exponential right there. You don't have to know that that's exponential. You just have to know it's not linear. If you see a curve, like you see a curve pattern. All right, direction, outlier, form, and strength. How strong do the dots correlate to the pattern that you see?
Very strong.
That's pretty strong. So I would say it's strong. That was easy, right? Let's do it again. Here's the other one. Blah, 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 blah. Okay, cool. Here's the other one. All right, you guys, what do you think? Direction.
Negative.
Yeah, this is definitely a negative direction. Outliers. Do you think there's any? Not really. Like an outlier is pretty obvious. It's like away from the rest of them. I don't really see one. Form.
Non-linear.
This one's actually linear. Because if I look at that, Royce, do I see like a curve or do I see kind of like where they're going into kind of a straight line? So I can kind of see that there's like a straight line right here. So this would be linear. And then what do you guys think about the strength? Is this strong? Is this like really close to a linear or is it like a little spread out? It's a little spread out. This would actually be probably like weak, or maybe you might say moderate, but probably this is kind of a little bit of a weak association here. So we would probably say weak. If you just like want to make sure you're right, you could say it's moderately weak. That'll work. Cool? But you can't say that it's weakly strong or strongly weak. No. All right, cool. What questions do you guys have about this? Easy? Fantastic. All right, let's look at this example. There we go. Is there a relationship between the amount of sugar and the number of calories in movie theater candy? Here are the data from a sample of 12 types of candy. This is real data, by the way. We're going to make a scatter plot to display the relationship between the amount of sugar and the number of calories in the movie theater calendar. You can do this by hand, but why when you can use your calculator, okay? Now, I'm going to give you guys a little pointer. If you guys will please go to Stat Edit. Everybody go to Stat Edit for me. Now listen. You have a lot of data in your L1 and L2 list. If you just start typing over top of it right now, then you're going to get to the end of this data and you're still going to have more data underneath. So if you guys will go up and highlight where it says L1 and hit clear. Don't hit delete, hit clear and then hit enter. It'll clear out that list. Same thing if you go over to L2, highlight where it says L2, hit clear and enter, and it takes out the data. That way you don't have to worry about accidentally leaving the old data there. All right, which one do you guys think is the explanatory variable? Do you think that the number of sugar grams is explaining the number of calories, or the other way around? Sugar is probably explaining calories. More sugar, more calories. All right, so you guys are going to put the sugar in the L1. Sugar goes into L1. Yes, you can put both of those columns in one L1 list. And then the calories will go into L2. Sugar goes into L1, calories go into L2. Make sure you match them up correctly. Make sure you keep them matched up correctly. Okay, once you have your data in, second, y equals, make sure that that first plot still says on. It should, since you saw your scatter plot earlier. So second y equals, make sure that plot is on. Then you can hit graph, zoom 9, and you should be able to see your data. Or see your scatter plot, I mean. Yes.
Do we still need to graph it?
Yeah, so here's the deal. So how are you supposed to get to sketch it, right? So
Wait, can you read off the steps here?
yep.
Oh, is that right? Oh, never mind.
You got it? Okay. So look, here's the deal. You guys are seeing this in your calculator, right? But like, how do you get it on your paper? So literally sketch, okay? So X and Y axis. Whee! You've got sugar on the X axis. You've got calories on the Y axis. And then you're just literally sketching what you see. So just kind of try to match the pattern of your scatter plot. So like,
So we don't need to like scale it or anything?
I'm going to show you, hang on. So match the pattern-ish. Okay, like literally there's that. Like that's close enough, right? Ish. Now, here's how you scale it. What's your lowest X value in your data? You can either figure out by looking at the actual graph or the data, or you can go to your scatter plot in your calculator, hit trace, and go find that lowest X value number. So like this is down here. What's your lowest X value? What is it? 44? Okay, so like I would do like, I don't know, 40. And then what's your highest X value? What's your highest X value? 136. So like, okay, so like 140. So look, I just scaled it. I literally just scaled it like that. If I want to throw in some extra little tick marks, I totally can do that. I can do the middle one, right? So what's halfway between 40 and 140? Yeah, I don't know either. 90? Yep. So I could throw that in there. There you go. There's an extra little scale, right? So that's all you have to do. You don't have to get crazy, okay? Same thing for the y-axis. What's the lowest y value? 370? 350? Okay. What's the highest?
790.
So like 800. There you go. That's pretty scaled, and I can throw the middle one in there if I want.
So what is it?
So what would be in the middle? 500? I don't think that's right, but okay. 550? Are you sure? Is that what you're going with? That's your final answer? Okay. All right, so like 550. Okay, cool. Hey, there it is, guys. I just scaled it. I sketched it. That's a sketch. Okay, it's a rough estimate. It's literally all you would have to do. Okay, part B says let's describe the association. How do I? What's my acronym for describing the association? DOFS, not socks. DOFS. What does DOFS stand for? Direction, outlier, form, and strength. Okay, guys, what direction is this going? This is a positive direction. Cool. Outliers. Do you guys think there's an outlier?
Yeah.
I think there is. Which one do you think is the outlier? This guy right here, right? So here's how you show an outlier when you're doing this. You actually need to give that coordinate. So if you go on your calculator again and hit trace and just hit left and right until you have an X on that dot, it'll tell you the X and the Y axis or the X and Y numbers. So what is the coordinate of that outlier? 79 and 790.
79, 79.
Okay. If you hit trace and you do left and right arrows, it'll get you to, you'll find that one. Form. What do you guys think? What's the, yes? So you have to use the left and right arrows. You can't hit the up. If it won't, hit trace again. And then do left and right. Does it, you have to.
Yeah, mine won't go there either.
Well, okay, so.
Hit trace.
You hit trace, only hit either the left or the right arrow. And what it's doing is it's going through your list and showing you each dot. So like if this one was the last one in the list, then it might be the last one you get to. Did y'all get to it?
Yeah.
Perfect. All right, form. What do you guys think? What's the form here? Do you think this is linear or not?
Here. It's legit.
You can kind of see the linear pattern, especially if I kind of ignore that outlier. And so this would definitely be linear. And then how strong do you guys think this association is? It's actually moderate. And right now, I will tell you guys, it's a little bit tough to see the weak, strong, moderate. Basically, like, the closer it is for these dots to line up, the stronger it is. This is actually not too bad other than the outlier. The outlier makes it moderate. So that is just kind of up for interpretation at the moment. We will get better at that next week when we throw in a new thing, okay? All right, cool. What questions do you guys have?